Hi, Levini. Again, this is Ermoy, and this time we're going to talk about radicals. We covered this already earlier in class, somehow, but this lecture video will talk about radicals and starting with equations, and then inequalities, and then we go into functions. So, to start, the important terms that we have to remember regarding radical functions, radical equations, and inequalities is what a radical is. A radical is this symbol right here. This is your radical. Now, what's inside it? Any expression inside the radical, especially when it has variables in it, is called the radicand. And having radicals inside this will give us radical functions. Another important term is what this n refers to. We call this the index of the radical. By default, you don't see a number here, which would mean the number is 2, and it refers to a power of 1 half. So please recall your laws of exponents to understand how radicals and its exponential form are supposed to go with each other. Now, since we'll be dealing with functions later on, solving radical equations should be well established. The idea is if you have a radical expression, we can solve the equation it comes with, especially if a variable is in the radicand, by taking the opposite or taking the inverse operation of it. Remember that radicals are also referred to as powers, but they're usually powers which are fractions. Square root refers to an exponent of 1 half. Cube root refers to an exponent of 1/3. Fourth root is an exponent of 1/4. So for us to solve an equation involving radicals and get rid of the radical symbol, we do the inverse of the power. Since the power for a square root is 1 half, it will only be gone if we take the square of the whole equation. Same with cube root. That symbol is cancelled out by a cube. Fourth root is cancelled out by the power of 4, and so on. So since we're involved with algebraic expressions and equations, we always follow correct algebraic properties. So to illustrate, here is our radical. The radicand is x plus 1. So for us to solve for x, we have to get rid of the radical sign. But for us to do that, we have to get rid of this first. Let's isolate our radical by moving the parts without the radical to the opposite side of the equation. So square root of x plus 1 becomes 11. And here, this allows us to get rid of the radical by squaring both sides of the equation. As you see here, the index is by default 2. So to get rid of that, we square the whole equation. And this allows us to get x plus 1 equals the square of 11, which is 121. Solving further, x is 120. Now we've solved the equation. For the second example, this is 7 times the cube root of 5x minus 7. So same idea. We'll get rid of the cube root, and to do that, we need to cube the equation. But let's start with getting rid of the 7. Since the operation is multiplication, 7 times the cube root, we get rid of that by dividing 84 by 7. And from here, we can take the cube of the equation so as to get rid of the cube root, allowing us to get 5x minus 7 equals the cube of 12, 1728. And then we get a value for x. Now, it's important that we still check solutions. Here, I'm not going to show how it's done. I leave that to you. But for us to get to this part, to make sure that we have actual solutions, is we substitute it back into the equation. You'll find that these values satisfy our original equations. So here are some more examples. This time we have here another term without the radical, another variable term without the radical. Here we have two separate radicals. So let's proceed with solving this. The idea is again isolate that radical. So we move x to this side of the equation. And same idea follows. We square both sides so that we get x plus 6 out of that radical. But still, since we're squaring, we have to perform the correct operations. So 14 minus x quantity squared gives us this. Now that we have an x squared, so recall how we solve quadratic equations, factoring, quadratic formula, it's up to you. And here we end up with these factors, x minus 19 and x minus 10. Now, since we have two factors, it gives us two possible solutions, x equals 19 or x equals 10. Take note that I said possible solutions. X equals 19 or x equals 10 are only possible solutions because of this. We squared the equation, so that leaves us to uh, the possibility of having one of these not a correct solution, especially because we have rules for radicals, if you remember. A radical, or to be more specific, even roots cannot have a negative inside it's inside the radical. Because we squared, we introduced another factor actually. Here we multiplied another 14 minus x. Here we multiplied another square root of x plus 6. So the effect is we can get values which do not really solve the equation. So what do we do now? We check. Any extra solution, the word itself, this is referring to extraneous solutions, refers to solutions that are not useful for the equation, or do not satisfy the equation. So we'll have x equals 19 checked to be placed there, x equals 10 checked to be placed to be brought back to the equation. And it turns out that only 10 is the solution. Only 10 will satisfy our equation here. For the second one, the square root of x plus 4 equals negative square root of 5x plus 8. The idea is again isolate one radical so that we can perform the square. So please be careful. Again, we're squaring this binomial, negative square root of 5x plus 8. Applying the correct way of squaring a binomial, we end up with this expression. And we still have one radical expression here, square root of 5x. So the same idea, we have to isolate this part. So all terms without the radical will be placed on one side. We now have negative 4x minus 60 equals negative 16 square root of 5x. And that brings us now to a simpler version. Here we have square root of 5x. Still a radical, so for us to get rid of the radical, we do another square. This time we now have x plus 15 squared, and then 4 times square root of 5x squared. 4 is squared, 16 times 5x. And we perform the same operations as this. We check it's factorable, so it brings us again to two possible values, x equals 5 or x equals 45. So just check what works. I leave that to you. Confirm that you're supposed to get only 5 as our solution. Now, let's try cube root. So the same idea follows. We have to isolate our cube root and then just need to perform the necessary operations. We cube the cube root so that we get x plus 7. We cube negative 4 as well. Hence, x equals negative 75. Now, for inequalities, the same idea will apply. It's the same thing we did a while ago. Uh, Treat them as equations. But again, we have restrictions specific to even roots. For square roots, fourth roots, sixth roots, eighth roots, and so on. We're lucky if it's only going to refer to cube roots because we have no restrictions for odd roots. So remember the restriction. In this case, 2x minus 3 under square root is less than 5. So how is this solved? Now, we'll have to look at it as two inequalities. One, first to the restriction, of course, 2x minus 3 should be kept non-negative. So it's always greater than or equal to 0. And of course, the other one is the whole inequality itself. So if we solve for the restriction, we know that x should be greater than or equal to 3 halves. If this were a function, again, this will be the domain. But our whole inequality refers to this, not only this part. So we still have to solve this one by doing the same thing we did with equations. We get rid of the square root, square both sides, and then solve for the value of x. This solves the inequality, but we have to keep this in mind. So we combine those two solutions. X should be greater than or equal to 3 halves, but less than 40. Now take note that we do not have an or equal to here, unlike this. We do not have an or equal to, so the solution will not allow or equal to as well. Our second equation, or inequality rather, follows the same idea. We have 4x plus 5 as our condition to check. The whole inequality can be solved by squaring both sides already. X is less than or equal to 95 over 4, or 23.75. The condition from 4x plus 5 tells us that x is greater than or equal to negative 5 over 4, or negative 1.25. Again, the set that applies these two will be the solution. X is between negative 1.25 and 23.75. Because we have an or equal to sign, it's allowed for our solution. Next, radical functions. For radical functions, again, they're just, um, again, the term is inverse. We will get to what inverse actually mean later on. Radical functions are inverses of power functions. We have quadratics, we have cubics, quintics, quartics, and so on. So this is the summary, again based on the conditions. Sorry. Radical function would look like this. You have the root. The radicand is an expression in terms of x. May have a coefficient outside or multiplied to the whole radical. Then maybe plus or minus another constant. The domain will have to depend on the type of root. Even roots will only concern themselves with x values that make the radicand non-negative. So what happens to the range? It gets restricted. If this a here, this coefficient is positive, that means we have the smallest value here, or this constant as the smallest value. If it's negative, this constant would be the highest value. Odd radical functions allow any real number for its domain. And then, of course, no restrictions for the domain. It allows us to get no restrictions for the range. So how are radical functions used? Here's one function used by doctors actually. I've shown this one in our introduction to functions. Body surface area is estimated through this function with height centimeters and weight kilograms. Speeds of tsunamis are estimated by using this function. D refers to ocean depth in meters. And then in finance and business, you'll have a lot of radical functions. This one estimates the quantity to be ordered, but that quantity is referred to as the most economic order. That depends on these parameters. You have A, quantity used for 1 year, S is the setup cost, I for holding 1 unit for 1 year. This one refers to the inflation rate of houses. Nth root, because we can calculate it in terms of the years that have passed from one original price or the initial price to the current price. So you'll have more of these functions later on. That's it for now for radicals. You'll be working on some items referring to equations and inequalities for our next meeting. See you.